All right, let's talk about polynomials for section P4. So polynomial in X, so this is this really horrible looking thing. This is just giving the general form of an algebraic expression. A sub n, so this is just a number, and x to the n is the exponent, and n has to be a non-negative number. And so the highest exponent that you see in a polynomial that is attached to the variable is going to be your degree. So if you have something like 3x squared plus 2, this is going to be degree 2. If you had 5x to the 17th plus x to the 5th plus x, this is going to be the 17th, so the degree, 17th degree. The leading coefficient is the number in front of the exponent, the highest exponent, so the x to the 17, that 5 is the leading coefficient. And here, 3x squared, that 3 is the leading coefficient. And a sub naught's the constant term. The constant term is the number that doesn't have an x. So in this second polynomial, we don't have a constant term, and in this first one, the constant term would be a 2. So the degree of a times x to the n, so it is letting us know that if we have x to the n, for us to use n for that degree, a cannot be 0. So a is going to be some real number. Okay, let's talk about adding and subtracting polynomials. So adding polynomials, we're going to be combining like terms, and to be a like term, you have to have the same variable with the same exponents. And adding is actually quite easy. So to add polynomials, we can actually just drop the parentheses. The reason for that is that technically we're distributing what's in front. So there's nothing in front of here, so it's like having a 1. And so if we distribute a 1, we get exactly what's here. So we're going to have negative 7x cubed plus 6x squared minus 11x plus 13. And for the second one, the reason we can just drop the parentheses, so this is plus, this is like having a positive 1 times all of these terms. So we're going to have plus 19x cubed minus 11x squared plus 7x minus 17. And now, whenever we go and combine our like terms, we're going to start with the highest exponent. So we're looking at this, the x cubed, so we have negative 7x cubed and a positive 19x cubed. So that's going to give us 12x cubed. And we have x to 6x squared minus 11x squared. That's going to be minus 5x squared. We have minus 11x plus 7x. So that's going to be minus 4x. And then we have this plus 13 and this minus 17. So now we combine those like terms, we're going to have minus 4. And this is as simplified as we can get this. So the 12x cubed minus 5x squared minus 4x minus 4. This is a degree 3, because that's the highest exponent attached to a variable. The leading coefficient is a 12, and the constant is a 4. All right, let's talk about subtracting. So subtracting does take a little bit more work. So the first part, this is going to be exactly the same, because again, if there's nothing here, it's like having a 1. So to get rid of these parentheses, it would be like distributing a 1. So it's going to be the 8x squared plus 7x minus 5. But the subtraction, it's asking us to subtract this whole thing. So we have to distribute this negative, which is like multiplying by a negative 1. And we're going to distribute until we come to the end of the parentheses, and then we stop. So it's like a negative 1 times a positive 3x squared, so minus 3x squared. And then it's like a negative 1 times a negative 4x, so plus 4x. And then we stop distributing this negative. We're going to continue on. We come to another negative against parentheses, so now we're going to distribute this negative to all three terms. So we're going to end up with plus 6x cubed plus 5x squared minus 3. Now we need to go through and combine like terms. And we're going to start with the highest exponent. And so we've got 6x cubed. Now we're looking for our squared. So we've got 8x squared minus 3x squared plus 5x squared. So this 8x squared minus 3x squared plus 5x squared is going to be plus 10x squared. We have plus 7x plus 4x. So it's going to be plus 11x. And we have this minus 5 and this minus 3, so minus 8. And that's going to be our answer. All right. Let's come down and start talking about the difference between addition and multiplication. So you see something here. So this 5x to the fourth plus 6x to the fourth. And we're going to be adding the numbers that are in front of the x to the fourths. So we have 5x to the fourth here. We have 6x to the fourths here. So in total, we have 11x to the fourths. In multiplication, so where we don't have a plus sign, where you're going to have them bumped together in parentheses, or we'd have a multiplication sign in between, we're going to be multiplying the numbers together. So the 5 times 6 is going to give us 30. And then we're going to use our product rule for our exponents. So x to the fourth times x to the fourth is going to be x to the eighth. So we'd end up with 30x to the eighth. One of the big mistakes that I see is that people will see something like 5x to the fourth plus 3x squared, and they think that they can somehow add it. But again, you can't add or subtract unless you have like terms. And these are not like terms because x to the fourth and x squared, the exponents don't match. With multiplication, however, you do not have to have like terms. So these two things can be multiplied together. So we would, again, the 5 times the 3 is going to give us the 15, and then x to the fourth times x squared. We're going to add our exponents and get x to the sixth. So let's talk a little bit more about multiplying polynomials. And the first thing we're going to talk about, or that I want to remind everybody about, is the product of the sum and difference of two terms. So also you'll hear like the difference of squares. So if you have the same thing with opposite signs in the middle, whenever you FOIL out, you're going to end up with only two terms. So for instance, if you have x plus 2 times x minus 2, remember FOILing, so our first, so x times x is x squared. X times negative 2 is negative 2x. 2 times x is going to be positive 2x. And then 2 times negative 2 is going to be a negative 4. This negative 2x plus 2x cancels out. So we're just left with x squared minus 4. So that's just a quick example of the product of the sum and difference of two terms. So let's look at multiplication, where it's a little bit more involved. So with FOILing, we're just taking this x and distributing it to these two terms, and then taking the 2 and distributing to these two terms. So here with number 1, we're going to use that same idea, but obviously there's 3 terms in the second polynomial. So we're going to do 2x times all 3 of these terms, and then the negative 3 times all 3 of these terms, and then we're going to combine like terms. 2x times x squared is going to be 2x cubed. 2x times negative 3x is going to be negative 6x squared. 2x times 5 is going to be plus 10x. Now we're going to do our negative 3 times x squared, so that's negative 3x squared. Negative 3 times negative 3x is going to be a positive 9x. And negative 3 times positive 5 is going to be negative 15. And now we need to go through and combine like terms. So we're going to start with our highest exponent. So we've got the 2x cubed, and this is the only cubed term, so 2x cubed. And now we're going to look at our squares. So we have negative 6x squared minus 3x squared, so minus 9x squared, plus 10x and plus 9x, so plus 19x, and then our constant of just minus 15. All right, so let's look at number 2. So number 2 is actually a little bit easier than number 1, meaning it's going to be a little bit shorter. The only trick is that because we have this squared outside these parentheses and there's a minus sign in there, we cannot distribute that squared into the parentheses. So we're going to have to actually write these out twice. So we've got 5x squared minus 3 times 5x squared minus 3. And then once we have it written out this way, hopefully you see that we can go ahead and distribute or multiply or FOIL, whatever you'd like to call it. So we're going to do 5x squared times 5x squared. That's going to give us 25x to the 4th. 5x squared times a negative 3 is going to be a negative 15x squared. Negative 3 times 5x squared is going to be negative 15x squared. And negative 3 times negative 3 is going to be a positive 9. Now notice the middle terms are not going to cancel out here because we do not have opposite signs. We have the same sign. So we are going to end up with 3 terms. So we're going to have 25x to the 4th minus 30x squared plus 9. Okay, so for number 3, we can first use the idea of our quotient rule with our exponents, where if we had something like x to the 5th over x cubed, we would know this is the same as x to the 5 minus 3 or x squared. Well, here instead of having x, we just have a bigger base. It's 2x minus 7. So this whole thing is what's being raised to the power. So we can use this same idea, only we're going to have 2x minus 7 instead of the x, and this will be to the 5 minus 3 power. So we have 2x minus 7, and then that's squared. And then just like number 2, because the square is around parentheses and there's a subtraction sign, we need to write this out. So if there's addition or subtraction within the parentheses, you can't just distribute the exponent. You're going to have to actually write it out. So we have 2x minus 7 times 2x minus 7. So now we multiply, we're going to get 4x squared minus 14x, and then minus 14x, and then plus 49. And whenever we combine like terms, we're going to have 4x squared minus 28x plus 49. So we already talked about the sum and difference of 2 cubes. So if you have the same things with the opposite middle sign, there's a shortcut where you can just take the first thing, square it, the second thing, square it, and put a subtraction sign in the middle. There's also, whenever you're squaring a binomial, a plus b all squared, that there's a formula you can use. So a squared plus 2ab plus b squared, and that's assuming it's a plus here. If it's minus, then the difference is the subtraction sign here in front of the 2ab. And there's even for whenever we're cubing a binomial, where we're going to have a cubed plus 3a squared b plus 3ab squared plus b squared, and then again, same idea if it's a minus sign here, only we're changing the subtraction, or changing to subtraction here and here. Now honestly, this is a lot to remember, and we're not going to use, especially these cubing ones, that much. So you would want to go ahead and just work through it. most of the time. However, if you're really good at memorizing formulas, this is a great way to save a little bit of time. All right, let's talk about factoring polynomials. So we're going to always look for common factors. That's the first thing you want to do. So in any factoring problem, the first step is to look for the greatest common factor amongst all the terms. And the greatest common factor, so we can use the abbreviation GCF, is an expression of the highest degree that divides each term of the polynomial. So basically, it's the biggest thing that goes into all of the terms of the polynomial. So for instance, if you have something like 15x squared plus 5xy, the greatest common factor is going to be 5x. So that's what's in common in both of these terms. So we could factor out the 5x, and then you just have to figure out 5x times what would give you the 15x squared, or whenever you factor 5x out of 15x squared, what's left? And that's going to be a 3x. And then 5x times what is going to give you 5xy? Well, times y, so it has to be a positive y. So this would be factoring out the greatest common factor. There's also factoring by grouping. So factoring by grouping is usually going to start with 4 terms. But first, let's look at an example that's already partially done. So x squared times 2x plus 5 plus 17 times 2x plus 5. The 2x plus 5 matches in both groups. So that is going to be the greatest common factor amongst this and this. So we can factor out that 2x plus 5. And whenever we do, we're left with x squared plus 17. So this is like the second half of factoring by grouping. Whenever you're factoring by grouping, you're going to typically have 4 terms. And so you're going to look at the first 2 terms together and the second 2 terms together. And you're going to pull the greatest common factor of the pairs of terms out front. So what I mean by that, the x cubed minus x squared, the greatest common factor here is x squared. So x squared, and then we're going to be left with x minus 1. Now this is a little bit tricky. So 99% of the time, whatever this sign is, goes right here. And so we now are looking at this 5x plus 5, and they have a 5 in common. So because we put the negative here, we're having to consider negative 5 times what gives us negative 5x. So negative 5 times a positive x is going to give us a negative 5x. And then negative 5 times what is going to give us a positive 5? Well, negative 5 times a negative 1 gives a positive 5. So one of the ways to make sure that you're on the right track is to see if your parentheses match. And indeed, our parentheses do match. So we're going to factor out our parentheses, so x minus 1, and they're going to be left with this x squared minus 5. All right, let's talk about factoring whenever our leading coefficient is 1. So that means that the very first term is going to have a 1, and that's an invisible 1. We're not going to write it. So whenever we're dealing with just a variable to a power here, whenever we go to factor, we know it's going to be 2 sets of parentheses, and that we can split this equally. So x squared splits into x and x. And now we need to think of numbers that are going to multiply to a positive 45 and add to a negative 14. So to multiply to a positive 45, we can do 1 and 45. 2 won't go in, 3 will. 3 times 15, 4 won't go in, but 5 will. 5 times 9. And then if we keep going, we're going to end up repeating 9 times 5, 15 times 3, 45 times 1. Now, to multiply to a positive means that we're going to have to have the same signs. So both positive or both negative. Because we're adding to a negative 14, that means that they both have to be negative, because there's no way to add two positives and get a negative. So we know they'll both be negative, and now we're going to look for the set of factors that's going to add to a negative 14. Well, right here, negative 5 and negative 9. So minus 5 minus 9. So we just factored x squared minus 14x plus 45 into x minus 5 times x minus 9. So let's do that again. So we've got x squared plus 8x plus 15. Again, because there's a coefficient of 1, a leading coefficient of 1, we know we're going to have x and x. So we need to multiply to 15 and add to 8. So to multiply to a positive 15, they'll both be positive or negative. And to add to a positive 8, they're going to both be positive. Let me correct that right quick. So 15 factors into 1 and 15, as well as 3 and 5. Well, obviously the 3 and the 5 are going to add to 8. So it's a positive 3 and a positive 5. All right, let's talk about using the AC method. So this is what you need to use whenever the leading coefficient is not a 1. We're going to first check to make sure there's not a common factor. So make sure there's not a common factor amongst all the terms. And for number 1, there is not. So we're going to jump right to the AC method. So the AC method, we're using the 9 times this 2. So that's the A and the C. And the reason that's an A and a C is because this is in the form ax squared plus bx plus c. So the 9 times 2, or the A times C, gives us 18. So now we're going to look at factors of 18 that add to a negative 9. So to multiply to a positive 18 means you're going to have the same signs. So both positive or both negative. So 18, so 1 and 18, 2 and 9, 3 and 6, and those are all of our options. Because we need to add to a negative, and they have to both have the same sign, then we know that they're going to both be negative. So negative 1 and negative 18 will not work, negative 2 and negative 9 will not work, but negative 3 and negative 6 will. So we know negative 3 and negative 6 will add to negative 9. So we're going to end up rewriting this problem, 9x squared. And then instead of this minus 9x right here, we're going to replace it with minus 3x minus 6x. So we're using these two terms right here to replace. And then we're going to keep that plus 2. And so now we have 4 terms. Once you get it to 4 terms, you're going to factor by grouping. So we're looking at these two together and these two together. With the 9x squared minus 3x, there's a 3x in common. So 3x times 3x would give us the 9x squared, and 3x times a negative 1 would give us this negative 3x. Again, whatever this sign is, you're going to keep it 99% of the time. And then with this 6x plus 2, there's a 2 in common. So we have a minus 2. So negative 2 times a positive 3x is going to give us a negative 6x. And negative 2 times a negative 1 is going to give us a positive 2. So to make sure we got everything, that we're on the right path, we're looking to see that our parentheses match, which they do. So since our parentheses match, we're going to factor out the parentheses. So 3x plus 1 times 3x minus 2. All right, so let's try this again with our next one. So the 6x squared minus 7xy minus 5y squared. You'll notice this is a little bit different because of the y squared. That's not a really big deal though. All that means is that our second terms and our factors are going to have y's. We're still going to use the AC method, so we're still going to do this 6 times our negative 5. So 6 times negative 5 gives us negative 30. And then we need factors of negative 30 that are going to add to a negative 7. Because we're multiplying to a negative, we know we're going to have opposite signs. So we've got 1 and 30, 2 and 15, 3 and 10, and hopefully you figured out that's the one that'll work. And if not, you could go to 5 and 6, and now we've listed all of them. So 3 and 10 will get us to a 7. We need negative 7 though, so this is going to be a negative 10 and a positive 3. So we're going to have our 6x squared, and then again, instead of the minus 7xy, we're going to do minus 10xy plus 3xy, and then minus 5y squared. So again, we're just taking this term and rewriting it using the factors that we found of negative 30. We're going to factor by grouping. So we're going to look at the first two and the second two terms together. And in the first two terms, 6x squared minus 10xy, there's a 2x in common. So 2x times 3x is going to give us 6x squared. 2x times a negative 5y is going to give us this negative 10xy. We're going to keep this sign, so plus. And this 3xy minus 5y squared, there's only a y in common. So you're going to pull y out. And y times 3x gives us this 3xy. And y times a negative 5y gives us this negative 5y squared. And if we look, we see that our parentheses match, which again is a really good sign. So we pull out the parentheses, so 3x minus 5y times 2x plus y. And again, so we pull out the parentheses and we're writing what's left. So that 2x and that plus y. All right, so the difference of two squares. So this we actually, hopefully we'll all be able to recognize fairly quickly after refreshing on the concept. So if you have a perfect square minus a perfect square, it's going to be really easy to factor. So it's just going to be the square root of the first one and the square root of the second one, and we're going to have opposite signs in the two factors. So for instance, we would square x to get x squared, and we would square 12 to get 144. Yep, excuse me, let me write the 2 up there. So now we're factoring this x, the first term goes in the first spot, the 12 goes in the second spot, and we need opposite signs. So plus and minus, or minus and plus, it doesn't matter which comes first. And again, we knew that we would be able to factor this way because we have a perfect square minus a perfect square. This has to be a subtraction symbol. If it's plus, then you're likely not going to be able to factor it, and other than pulling out a common factor. If you want to double check your work, again, you can always FOIL or distribute or multiply, whatever you want to call it. So we would do x times x, which would give us x squared, x times a negative 12, which would be a negative 12x, 12 times x, which is going to give us plus 12x, 12 minus 12 times a negative 12, it's going to be a negative 144. These two middle terms are going to cancel out, and you're left with x squared minus 144. So let's look at our next example. So this one's a little bit trickier because we're trying to figure out what we're squaring to get to this 81x to the fourth, and the what we square to get to 1 hopefully is not too bad. So to get 81x to the fourth, we have to square a 9 to get to the 81. And then to get to x to the fourth, we have to square x squared. So 9x squared, all squared, is going to get us 81x to the fourth. And then 1 squared gives us 1. So again, following the format, We're going to have the 9x squared. And the first part, the 1, and the second part, we're going to have opposite signs. So plus and minus or minus and plus. So at this point, a lot of people would quit and they would feel like they had the correct answer. But really, it's just one step towards the correct answer. If you look, that 9x squared minus 9, those are still perfect squares. So we still have to factor this part. So we're going to pull this down. We're just going to rewrite it. We cannot factor this because of this plus symbol. So I'm just going to rewrite this. So we have 9x squared plus 1. And then we need to factor this portion. So it's 2 sets of parentheses. And then figure out what we're squaring to get 9x squared. Well, we're going to square 3x. So we're going to have 3x. And then we need to figure out what to square to get 1, which again is just going to be 1. And then opposite signs. And it doesn't matter if you do the plus or the minus first. This is going to be the final answer. So it can be a little bit tricky whenever you're dealing with exponents larger than 1 to begin with. So keep an eye out for that. If it looks like the difference of squares and you have exponents higher than 2. All right, let's talk about factoring the sum or difference of 2 cubes. So unfortunately, this is a little bit to memorize, and that's probably going to be the only way that, that we're going to be factoring cubes is just through the memorization of the process. But there's a pattern. So you've got something cubed plus something cubed, and I'm going to refer to this as the first thing and the second thing. And then I'm going to explain it in a very not mathematically correct way, but this is how I remember. So for instance, if we have x cubed plus 27. Well, this is obviously x cubed plus 3 cubed. So the x is being cubed, the 3 is being cubed. The first thing I'm going to refer to will be x, and the second thing I'll be referring to will be the 3. So the pattern is a short set of parentheses, a long set of parentheses. For the symbols, it's going to be same sign, opposite sign, plus sign. And now we just need to fill in what goes in between all the parentheses. And to do that, the way I think of it is 1 of the first, 1 of the second, 2 of the first, 1 of each, and 2 of the second. And so that's kind of what I repeat to myself. So the x plus 3 is pretty obvious, so 1 of the first plus 1 of the second. 2 of the first, taking whatever the first thing is and squaring it. So this will be x squared, 1 of each, minus 3x, because we're multiplying, and then plus 9. So let's look at another example right quick. So with the x cubed minus 64, so this is obviously the x cubed minus, and then 4 cubed will give us 64. So we have a short set of parentheses, a longer set of parentheses. We're going to use same sign, opposite sign, plus sign. 1 of the first, 1 of the second, 2 of the first, 1 of each, and 2 of the second. And when we go through and simplify this, we're going to have x minus 4 times x squared plus 4x plus 16. So we'll try again. So with this 8x cubed plus 125, you have to cube 2x to get 8x cubed plus, and you have to cube 5 to get to 125. So again, same process. Short set of parentheses, a long set of parentheses, same sign, opposite sign, plus sign. We're going to have 1 of the first, 1 of the second, 2 of the first, 1 of each, and 2 of the second. So, whenever we simplify, we're going to have 2x plus 5. This 2x squared is 4x squared. And then the 2x times 5 is going to be minus 10x. And then the 5 squared will be plus 25. So here's a general strategy for factoring polynomials. If there's a common factor, factor that out. So look at all the terms and see if there's anything in common first. Then, if there's 2 terms, figure out if it's a difference of squares. If it's a difference of squares, you're just going to follow this format. If it's the sum of cubes or the difference of 2 cubes, we're going to use the formats we just looked at. And then some of the other formats that are a little bit more difficult to recognize whenever you're trying to factor would be if you had a perfect square trinomial. So the a squared plus 2ab plus b squared form would factor into a plus b squared. Or the a squared minus 2ab plus b squared would factor into a minus b squared. Again, those are a little bit harder to recognize, and oftentimes we'll be using the AC method for those if there's a leading coefficient that's different than 1. If there's 4 or more terms, you're going to try factoring by grouping. And then also, once you've factored, you're going to continue checking to make sure that each of the factors cannot be factored any further. So for instance, the problem that we were working on, so here, where that 9x squared minus 1 could be factored further, you have to factor completely whenever it says factor. So you would need to go that extra step. Alright, let's talk in section 6 about rational expressions. So a rational expression is the quotient of 2 polynomials. So basically, it's just a big nasty fraction. Where you're going to have a polynomial, top or bottom, or both. So the set of real numbers for which an algebraic expression is defined is the domain, because rational expressions indicate division, and division by 0 is undefined. We have to exclude numbers from a rational expression's domain that make the denominator 0. So what that's essentially saying is that x cannot be any value that's going to make the bottom 0. So if to figure out the excluded values, if we take the denominator, determine that it cannot be 0, and then solve, we would add 3 to both sides here. And we would get that x cannot be 3. So x cannot be 3 for this first one. For the next one, to figure out the numbers excluded from the domain, we're going to have our x squared plus 4x minus 45 cannot be 0. So we're going to go through and solve this by factoring. So because there's a leading coefficient of 1, we know there's going to be x in the front of both of these. And then we need to multiply to a negative 45 and add to a positive 4, which is going to mean opposite signs to multiply to a negative and add to a positive 4. So negative 45, we got 1 and 45. We've got 5 and 9. And I skipped over 3 and 15, but hopefully the 5 and 9, you'll see, will get us to 4. Because it's adding to a positive 4. The larger number has to be positive. So it's going to be a positive 9 and negative 5. So once we have these factored, we're going to say that each of these cannot be 0. So x plus 9 is not going to be 0. And x minus 5 is not going to be 0. So whenever we subtract 9 from both sides, x is not going to be a negative 9. And we add 5 to both sides, x is not going to be a positive 5. So So those are going to be the two numbers that are excluded from the domain of the second example. All right, let's talk about simplifying rational expressions. So one of the ways that we can simplify is to look at see if there's any common factors, top and bottom, and cancel them out. To do that, though, oftentimes we're going to need to factor the numerator and the denominator, or the top and the bottom, and then see if anything cancels. So for number 3, this 3x minus 9, we can rewrite that as by pulling a 3 out as being a common factor. So it's going to be 3 times x minus 3. And then for the denominator, the x squared minus 6x plus 9. We know there's going to be x. And then we need two numbers that are going to multiply to a positive 9. So it multiplies to a positive. It's going to have the same signs. And adds to a negative 6. Means both signs will be negative. And 3 and 3 will work. So minus 3 minus 3. Now looking at this, hopefully you see that the x minus 3 matches on top and bottom. There's 1x minus 3 on top, so we can cancel 1x minus 3 on bottom. And so our result's going to be 3 over x minus 3. So let's look at our next example. So x squared minus 8x plus 16. The x squared minus 8x plus 16 is going to factor to where we have x in the beginning of both sets of parentheses, and then a number that's going to multiply to a positive 16, and then they're going to add to negative 8, and that's going to be negative 4 and negative 4. And then denominator here, we have a common factor of 3, so we're going to pull that 3 out, and we're going to be left with x minus 4. And again, hopefully you see that the x minus 4, there's going to be there's only 1 on bottom, so we can only cancel 1 on top. And we're going to end up with x minus 4 over 3. All right, let's talk about multiplying rational expressions. So whenever we're multiplying rational expressions, we're going to want to factor all of the numerators and denominators. We're going to want to divide where we can. So whenever we say divide, we mean like simplify. And then we're going to multiply what is left. So let's go ahead and work through here for our multiplying, these two rational expressions. So I'm going to start rewriting this first rational expression by factoring out the common terms. So this 6x plus 9, that's going to be 3 times x plus 3. And then this 3x minus 15, again, I can factor out a 3, and I'm going to be left with x minus 5. And then times x minus 5 on top, that cannot be factored. And on bottom, this 4x plus 6, we can factor out a 2. So in factoring out that 2, we're going to be left with 2x plus 3. And if we look, the things that we have in common on top and bottom is going to be this x minus 5 and the 3's. Now once we're multiplying fractions, then we can reduce from the top and bottom regardless if it's in the same fraction or not. So that's the reason we can reduce this x minus 5 and x minus 5. So that's going to leave us with x plus 3 on top, and that 2 times 2x plus 3 on bottom. So this is whenever we're multiplying rational expressions. If we're going to divide rational expressions, we have to keep the same ideas that we use whenever we're dividing fractions in common or in mind. So keep, change, flip. So the first rational expression is going to stay the same. We're going to change the division sign to multiply, and then we're going to flip the second rational expression. So for this next example, we're going to do keep, change, flip, and then we'll go through and factor everything. So keep, the x squared minus 4 stays the same, over x squared plus 3x minus 10. We're going to change from division to multiplication, and we're going to flip. So what was the denominator becomes the numerator, x squared plus 8x plus 15 over x squared plus 5x plus 6. And now we're going to want to go through and factor the numerators and denominators, or the tops and bottoms of both of these rational expressions. So x squared minus 4 is the difference of perfect squares. So that's going to factor into x plus 2, x minus 2. The bottom, the x squared plus 3x minus 10, we know we're going to have x in the beginning of both sets of our parentheses. And then to multiply to a negative 10 and add to a positive 3, we're going to be thinking about 5 and 2. Because we're adding to a positive, the larger number has to be positive. So it's going to be a plus 5 and minus 2. And for the second rational expression, the x squared plus 8x plus 15, we're going to factor to where we have x in the front of both sets of parentheses. And to multiply to 15, we can use 5 and 3. That will also add to 8, both positive. So plus 5, plus 3. And then x squared plus 5x plus 6. This one actually trips up a lot, will trip a lot of people up. So we're going to put x in the beginning of the parentheses. And then multiplying to a positive 6 and adding to a positive 5 means both numbers have to be the same. So it's going to be plus 2 and plus 3. Now we're going to look for everything that's in common, top and bottom, and cancel or reduce. So x plus 3's cancel, x plus 5's cancel, x minus 2's cancel, and x plus 2's cancel. Well, keep in mind that whenever everything goes away, or whenever something goes away with multiplication or division, you're left with a 1. So right now, we're left with just a 1 over 1, better known as 1. All right, let's talk about adding and subtracting rational expressions with the same denominator. So if they have the same denominator, it's going to be a little bit easier. But we're going to also look at adding and subtracting rational expressions with different denominators. So let's first add with like denominators. And then we'll come back and talk more about adding and subtracting with different denominators. So whenever you have the same denominator, then really we're just thinking about putting this symbol up here and putting parentheses around both sets of these. So because we have a common denominator, we could actually rewrite this as 4x plus 1 plus 8x plus 9 all over 6x plus 5. We would go through and combine our like terms, or we would do the addition. And again, remember, whenever we're adding polynomials, that in its addition, we don't have to worry about going through and distributing or changing any signs. So we're going to end up with 12x plus 10 over 6x plus 5. Now, one of the tricky things we have to remember is that we're always looking to see if we can factor. So the 12x plus 10, there's a 2 in common, so we can pull a 2 out on top. So we're going to have 2 and be left with 6x plus 5 on top over 6x plus 5. And now the 6x plus 5s are going to cancel. And we'll just get 2. Now let's go back and talk about adding or subtracting whenever we have different denominators. So now we have different denominators. What we can essentially do is multiply the other rational expression by the denominator. So this a over b plus c over d, we can multiply by d, top and bottom here, and we can multiply by b, top and bottom here. That's going to give us bd for both of the denominators. We can go through, and one of the ways that might be faster than this is actually finding the least common denominator and then figuring out what each rational expression is missing to have the least common denominator. And then once we do have a common denominator, we're just going to go through and add and subtract the polynomials on top. And we'll also simplify if possible. So for our second example, we want to factor the denominators so that we can have an easier time finding the least common denominator. So we've got x plus 5 over x plus 2, x minus 2. And that's just factoring this x squared minus 4 into x plus 2x minus 2. And then minus x plus 1 over x minus 2. So we have an x minus 2 in both denominators, but we have this x plus 2 over here. So for our LCD, the things we have in common, we're going to write down one time. So x minus 2 we have in common in the denominators, and then also anything else that one or more of the denominators have. So this x plus 2 is also necessary. So the first rational expression has the proper LCD, has the proper denominator, but the second rational expression does not. So we're going to have to multiply by x plus 2 on the bottom, and because we can't just multiply the bottom of a fraction, we have to do the same on top. So now we're going to have this x plus 5 over x plus 2, x minus 2, minus x plus 1 times x plus 2 over x plus 2, x minus 2. So again, matching denominators. And then we can go ahead and combine this to be x plus 5 minus x plus 1 times x plus 2 all over x plus 2 times x minus 2. Now, this top actually takes a little bit of thinking. We can't just subtract one of these over here on the right. We also can't just reduce. So we actually need to multiply these two together, and then we need to distribute that negative symbol. So we're going to have x plus 5 minus, and if we FOIL this, we're going to have x squared. This will be plus 2x plus x, so plus 3x. And then the 1 times 2 will be plus 2 all over x plus 2, x minus 2. And then we're going to distribute. So we've got this x plus 5, and then we distribute this to get minus x squared minus 3x minus 2 all over x plus 2, x minus 2. And now we're going to combine our like terms on top. So actually these parentheses aren't necessary at this point, so this is a positive. So let me go ahead and erase those. Okay, so we're going to combine our like terms. So we're going to have a negative x squared. We have a negative 3x and a positive x, so minus 2x. We have a positive 5 and a negative 2, so that's going to give us a positive 3. And again, this is all over x plus 2, x minus 2. Now, one of the things we've mentioned is looking before so we need to factor this top to see if we can reduce. Looking for a common factor amongst all of the terms. Well, there's not a number in common, and there's not a variable in common. But I don't like having this negative in front of the x squared. So we can actually factor out a negative 1. So this will be negative 1 times x squared plus 2x minus 3 all over x plus 2 times x minus 2. And now let's look at factoring this x squared plus 2x minus 3. So we're just going to rewrite that negative 1. And the x squared plus 2x minus 3 is going to factor to where we have an x in front of the parentheses. And we need to multiply to a negative 3, so opposite signs, and add to a positive 2. So negative 3 and 1 will do that. Sorry, positive 3 and negative 1 will do that. So these are going to add to a positive 2 and multiply to a negative 3. So we have that over x plus 2, x minus 2, and sure enough, nothing reduced. So this could be a final answer, or we could have actually just stopped up here. We're going to talk about rational expressions a little bit more, only we're going to talk about complex fractions. So complex fractions basically just means you've got fractions within fractions. So here are two different examples where we have a fraction in the numerator and a fraction in the denominator, or here's one where we have a fraction in just the numerator, or just the top. So let's talk about a couple of ways to work with these. Well, I'm going to actually discuss one way to work with these. The way that I think is easiest is to look at the denominators in the top half and the denominators in the bottom half and figure out what the least common denominator would be. So for number 1, whenever we're looking, we see an x and an x. So the LCD would just be x. So we're going to multiply this entire fraction by x over x. Because again, we can multiply by anything that's equivalent to 1. So what's going to happen is that we're going to have this 8 plus 1 over x times x, and this 4 minus 1 over x times x. So whenever we distribute, we're going to end up with 8x, because the x times the 8, and then when we go here, the x's will cancel and we'll just have plus 1. So we're going to have 8x plus 1 on the top over, and on the bottom we're going to do the same thing. So we're going to distribute this x, so we're going to have 4x, and then whenever we distribute here to the second term, it's going to be minus 1, because again these x's are going to cancel. So we're just going to end up with 8x plus 1 over 4x minus 1. There are no common terms, and there's nothing that we can reduce. Do keep in mind that whenever you have plus or minus signs, that you can't just scratch out things that match. So one of the bigger problems I see would be somebody trying to reduce the 8x and the 4x, but we can't do that because we're looking at 8x plus 1 as a factor and 4x minus 1 as one factor. So if it helps, think of it as having parentheses around it because of that plus sign. If we had something like x and x, then we could cancel those because they're being multiplied. But again, we don't, so the 8x plus 1 over 4x plus 1 is finished. Alright, let's look at the next example. So the next one takes a little bit more thinking. So if we look at the denominators in the top and the bottom, we're going to see x minus 2 and x squared minus 4. Well, for our LCD, we know for sure there'll be an x minus 2 in there. And then we need to factor this x squared minus 4 to see what's going on. So just as some side work, x squared minus 4 is the difference of squares, and so we can factor that into x plus 2 and x minus 2. Well, then if we have x plus 2, x minus 2, and then in this top, the denominator in the top is x minus 2, we only have to put that one time. So there's the x minus 2, but we're missing x plus 2. So this, the x minus 2, x plus 2, is going to be the least common denominator. So we're going to take our problem and we are going to multiply by the least common denominator. So we're multiplying by this x plus 2x minus 2 on top and bottom. And it doesn't matter if you have x plus 2 first or the x minus 2 first. And so what ends up happening is we're going to end up distributing this, so this whole thing, to both of these terms. We're going to distribute this whole thing to both of these terms. So I'm going to write out probably more work than you all would typically write out. So this is going to mean that we're going to have this x over x minus 2. Actually, let me do that in black. So here's the original top half, or numerator, and then we need to make sure that we're multiplying that by x plus 2, x minus 2, and that's going to be true for both terms. And we're going to do the same thing in the denominator and the bottom half. So we have that 3 over, and instead of this x squared minus 4, I'm going to go ahead and factor that into x plus 2x minus 2. And again, we're having to multiply both of these by the x plus 2x minus 2. All right, so let's look at what all is going to cancel. So just looking at this top half first, this x minus 2 on the bottom is going to cancel with this x minus 2. And so whenever that cancels, the top is going to be left with x times x plus 2 for this first part. And then over here we have 1 times the x plus 2, x minus 2. So nothing reduced there. And we're going to come back and simplify this in a minute. Okay, and now let's look at the bottom half. So the x plus 2's are going to cancel here. The x minus 2's are going to cancel here. So we're just left with 3. And then here again, nothing's going to cancel. So we can just go ahead and rewrite the 1 times x plus 2, x minus 2. All right, now we're going to go through and simplify the numerator and the denominator, the top and the bottom. And that's going to take a couple of steps, but it's just your basic algebra. So we need to distribute here. So we're going to have x squared plus 2x, so from distributing here, and then plus, so 1 times this. The 1 changes nothing, but the x plus 2x minus 2, we can go ahead and FOIL or multiply. And we already know that that's going to equal x squared minus 4. And we'll come back and combine like terms in just a minute. And then for the denominator, the 3 will just be a 3. And then again, this 1 doesn't change anything whenever we multiply, but that x plus 2 times x minus 2 is going to give us the x squared minus 4. So plus x squared minus 4. And if we combine like terms, on top, we're going to have 2x squared plus 2x minus 4 all over x squared. And then we have minus 4 plus 3, so minus 1. And so we're just about done, but we need to factor just to make sure that there's nothing that we will be able to cancel in the end. So to make sure that we're done simplifying or reducing. So on top, whenever we look here, hopefully you're going to notice that each of these coefficients is an even number. So we can pull a 2 out. So our first step is going to be pulling that 2 out. We'll be left with x squared plus x minus 2. And then we'll go ahead and just rewrite the bottom. And so the top, the x squared plus x minus 2, that's going to also factor. So I'm going to rewrite the 2, and then we're going to factor that x squared plus x minus 2. And we know it's going to be x and x. And then two numbers that will multiply to a negative 2, so opposite signs, and add to a positive 1. It's going to be a positive 2 and a negative 1. And now let's factor the bottom. So this x squared minus 1, the difference of squares. So we're going to have x plus 1 and x minus 1. And then here, these x minus 1s are going to reduce. So our final answer ends up being 2 times x plus 2 over x plus 1. I know that's a good bit of work, but hopefully the concept is clear and you